So I just gave you a bunch of information in construct understanding, but no numbers to work with. We're going to play with numbers now. In example 1, it tells me that we have a point P at 4 and 7. So if it's at 4 and 7, then my x is 4 and my y is 7. So I can go over to my graph and go 4 over and 7 up and put a point there. There's point P at 4 and 7. Really important to get into the habit of drawing these things out as you go, because it's going to get more complicated, and it's always nice to organize your thinking by drawing a picture of what it is that you're talking about. Now the first thing they want to know is the distance r from the origin to P. Now the origin is always the 0, 0 on your graph. So we want to find out what that is, which they call r, and they refer to it as the terminal arm. So it's on the terminal arm, which means that it is just going out from the origin in a straight line. So they say, what is the distance r? Well, I can draw my little triangle down here. Whoa, that was kind of a funky line, but you'll just have to deal with it. And recognize that this distance here is 4, and this distance here is 7. So I can use the formula that we came up with last time. If I want to find r, I have to take the square root of x squared plus y squared, which in this case is 4 squared plus 7 squared. So 4 squared is 16, 7 squared is 49. It's going to give me, what, 65? Yeah. The square root of 65. Now here's a fun turn of events. Your book usually doesn't want you to actually figure out the square root of a number that isn't perfect. And the reason for that is that the square root of 65 is an exact amount. As soon as I actually find out what the square root of 65 is, it's going to be an irrational number with a non-repeating, non-terminating decimal, and I'll have to round off. So if you round off, it's not exact. When your book says find the exact value, it means don't try to solve any roots that aren't perfect. So this is it, we're done. R is the square root of 65. Yay! Now, moving on, it asks us to determine the primary trigonometric ratios of theta. So this is theta in standard position. It's always from x upward. And the standard trigonometric ratios are sine, cos, and tan. Now we know that that side is 7, we know that that side is 4, and we just figured out that this side is the square root of 65. Looks like I need a new pen. So I'm going to, it doesn't really matter which one I start with, I like sine. So sine of my theta is going to be opposite over hypotenuse, or as always in this case, y is the opposite and x is the adjacent, and r is the hypotenuse. So sine is always going to be opposite over hypotenuse, which is y over r. So we have a new way of saying sine now. We can say sine is y over r. And when we plug in our values here, that's going to be 7 over the square root of 65. Now you might be tempted to actually solve that, but the exact trigonometric ratio is that. If you try to solve it, you'll have to round off the decimal, and that's no longer exact. So we move on. Let's do cos. Cos of theta is adjacent over hypotenuse, so it's going to be x over r. Always in standard position, always you can use these patterns. So x is 4 over the square root of 65. Now, the only one left to do is tan. And tan of theta is opposite over adjacent, so y over x. Tan is y over x, which in this case is 7 over 4. Now the final thing they want us to do with this question is actually solve for theta. So you could choose any of these ones. I would choose 10 because it's easier. It doesn't have any roots in it. So to solve for theta, that might be too low. Let's see. I'll just write it up a little higher. It's going to be second function tan of 7 over 4. So I go in my calculator, I make sure I'm in degrees, not radians, in my mode. So I could hit my mode button and make sure I'm in degrees. And second function tan, 7 divided by 4, close bracket, gives me, and it says to the nearest degree, so 60 degrees is fine. So at that very last part, they're okay with rounding off. Does 60 degrees make sense? Well, let's look at the triangle. It's more than 45 because it's higher than halfway. So yeah, 60 degrees makes sense.